Hello students, welcome to the next lecture on the testing of the hypothesis. Today we will discuss about the solved examples of the F distribution test. I will explain you all the questions. I will cover the 7 to 8 examples in this lecture, and all are covered with the help of the 3-step rule. Myself, Dr. Garg. You can simply follow this link for finding the various videos on the probability and statistics. So let's start with the F distribution. F distribution is also called as the Fisher F distribution, and it is widely used in the statistical testing. Why there is a need of the F test? When you want to compare the ratio, when you compare the two or more variances are there. So this F distribution is used to estimate the ratio of the two normally distributions are there. Or in other words, you can say whether there is any significant difference between the two samples variances x1, x and y or not. Or you can say whether there is any significant difference, whether the variances of the two independent estimates are homogeneous or not. So you can say both have the same meaning. So in order to check whether this condition holds or not, we will apply the F test. As we have seen in our last lectures, the t-test is used to compare the mean, while the F ratio or the F distribution is used to compare the variance of the two distributions. Say you have the one distribution x1, x2 up to the x of n1, y1, y2 and are the two independent random samples, and they are taken from the normal distributions or the normal populations having the equal variance. Now your target is to check whether this is true or not. So under the null hypothesis, you have to find the S1 is the sample standard deviation, S2 is here. When S1 is greater than, then you can write here. Otherwise, you can write this value as S2 square upon S1 square whenever S2 square is greater than of S1 square. What is the S1 and S2? These are the unbiased estimator of the population variance. We also know that there is a capital S. Capital S is called as the unbiased estimator. We also know there is a one sample variance, which is nothing but my xi minus x bar divided by n1. This n1 is the number of the elements, while this n1 minus 1 is called as the degree of freedom that we have discussed so many times in our previous lectures. So remember that whatever the value of the S1 or S2, whichever is the larger, then you have to always place in the numerator. So when S1 is greater than of the S2, then you have to write S1 square over this. If you have the variance of the sample x and y, which is denoted like this way, then you can define the capital value of S1 from here. You can find the numerator value. This is n1 of small s1 square. I can substitute here. This is n1 small s1 square upon n1 minus 1. Similarly, capital S2 square is n2 S2 square upon n2 minus 1. So therefore, the relation between the unbiased estimator of the population variance as well as the variance of the sample is defined by equation number 1. Now, once we know this is the F statistic, which is the ratio of the two variances are there, and it follows the F distribution with the probability density function here. What is the eta? What is the new one? This is nothing but the degree of freedom of the sample x. This is the degree of the freedom of the sample x. Similarly, the degree of freedom of the sample 2, that is called as the eta nu 2, is the sample y is there. And what is the b? B is nothing but the beta distribution, which can be written here, or it can also be written as m minus 1 factorial n minus 1 factorial divided by m plus n minus 1 factorial if your m and n are my positive integers, and nu1 and nu2 are my degree of freedom. Next thing is, what is the F distribution? So this is the table which is at the level of significance, say 0.05. What is the meaning of that? If say you have S1 square upon S2 square, where nu1 is the degree of freedom of the sample x, nu2 is the degree of freedom of the sample y. So assume the degree of freedom is say my 3, nu2 is say my 5. Then from this table you have to read the value at the level of significance 5. Degree of freedom is my 3, 5. Sometime it is also be written like this way, f of 0.05 3, 5. Make sure the first degree of freedom, either this 3 or the first one, is always the degree of freedom of the numerator. So if I write as a S1, then the degree of freedom is mu1. How you read this value is you can see the degree of freedom of the numerator. So it's a 3. The degree of denominator is my 5. So you can check the values of this common value is my 5.409. These are the required result. But if the F ratio is defined like this way, then the degree of freedom will be my 5, 3 at the 0.05. So the numerator is my 5. You can see this is my 5 and 3 will be my here. The common value is 9.013. So this is the way you can check the degree of F values from this table. So whatever the value we have obtained from this, we can call as the F table value, as I discussed that F3, 5 of 0.05, that is my here. So this value is my F of 0.49. This is called as the critical value. So we all know that what is the critical value, which divides the acceptance region and rejection region into the two disjoint parts. Then this F value we have obtained from this table called as level of significance. Now we can define the 3-step rule, which are give us the two answers, whether the population's variances are same or the variances are homogeneous or not. Though we will define the testing of the hypothesis, define the hypothesis H0 and H1 in the step number 1. Step number 2 is F statistics and step number 3 is conclusion. Step 1 we will define the H0 and H1 like this way, that is variances are same and variances are not same. Step number 2 we will define the F statistics like of this, whenever S1 square is greater than of S2 square, else if my S2 square is greater than of the S1 square, then we have to define as S2 square upon S1 square, where S1 and S2 are my unbiased estimator defined like here. Once you define the step number 2, then in the step number 3 we will find the degree of freedom nu1, we will find the degree of freedom 2, and we will make this table out there. This value we can take from the F table corresponding to the degree of freedom nu1 and nu2, and we can summarize this value as here. And after that we can check whatever the value we have obtained from the step 2, if this value lies in this accepted region, that is F less than of this, then we are failed to rejected H0, or we always use the word may. Remember, this word may will be there, otherwise we will rejected H0. Now in order to explain this 3-step rule, we will cover the 7 to 8 examples so that you can understand very well. So let's start with this first one. So say there are the two samples, this is the X and Y. It consists of 9 elements, say N1 is 9 and this is my 8. The sum of the squares of the deviations, sum of the squares of their deviations from their respective mean is my 160, and from their respective of the second sample is my 91. Can you say these two samples are drawn from the normal population with the same variance? It means you have to make a decision. So we have to apply the F statistics because our target is to make them variance. So we apply these statistics. So H0 and H1 will be here. Now we will define this if S1 square is greater than of the S2 square. This is given to you. We can define the value of the S1 square. We can define the value of S2 square like of here. This is the formula of the S1 square. This value is by 160 divided by N1 minus 1 here. Clearly says that S1 square is greater than of the S2 square. So therefore F is my here. So what is the value of this? It is nothing but 20 divided by 30. That is my 1.5. Step number 3, we will compute the degree of freedom. So the degree of freedom is S1. Firstly S1, the S1 degree is my N1 minus 1, that is 8. Degree of freedom of the second is my 8 minus 1 is 7. So therefore this value we need at the 8,7. Level of significance is not given, so we can consider as the 0.05. This value we can taken from the table. So look at that, 8 comma 7. So first value is my 8, next value is my 7 denominator, so the value is 3.726 is there. I can write either as a 2 decimal. Now we can check where it lies. This is my 0, 1.54 is lies here. Since this value is less than of this, so we may fail to reject it this one, or we may accept it H0. What is that? This is accepted. So what is the meaning of that? The two variances have same argument. So we may conclude that two samples are drawn from the same variance. Look at the second example. So in the sampling results of the consists of the 6 elements. In the first sample 6, second as 11. This is a capital S is already given to you. 3.6, capital S is already given to you. Check whether there is any significant difference between the S1 and S2. That is my variance. So again we have to apply the F test. So we have to start with here, because there is no given to you, so we have to start from here. Since S1 is greater than of the S2, so we have to apply this S1 square upon S2 square. So 3.6 square divided by 2 square. So the answer is 3.24. What is the step number 3 is conclusion. So what is the degree of freedom of the numerator? That is the S1. So what is the degree of freedom of the S1? That is my N1 minus 1, 5. Degree of freedom of the second one is a 10. So therefore we need this value as 5 comma 10. So this value we can take from the table, its value is here. Compare this value, 3.24 lies in the accepted region. So we can say we fail to reject it H0 and we may accept it H0. So once this is accepted, it means there is no significant difference between their samples populations or the populations variances. Look at the another one. So two samples are drawn of size is my 7 and is here, and the variances are here. What is the meaning of this? This is the sample variance, so it's denoted by small s1. Remember, it is not capital S1 because it's a sample variance. So sample variance is denoted by small s1 and s2. Can you say 9.6, that is s1 is greater than of the s2? That is the target of this problem. Now in this case it's a sign of the greater than, so we have to define like of this way, because equality not be there, so it is not belongs to the H0. What is given to you here? As small s1 is given to you, small s2 is given to us. That means this is here, but our target is to find the capital S1 here. How you find this value? Upon n1 minus 1. So based on this small s1 I can find this numerator value. What is that? This value is nothing but small s1 here, so I can take this value in here. I can compute this value. This is n1 of this. Now I can substitute this value here. This is 9.6 over 6 and so on. Now clearly sees that S1 square is greater than of the S2, so we can define the F ratio as S1 upon S2. Now we can find the degree of freedom. Look at that S1. What is the S1 is 1. What is the degree of freedom is 7 minus 1, 6, and here is 8. And we can take this value from the table. We will get this number. Where is 2.076? It lies in accepted region, so we may accept it H0. So we may accept it H0. You can see 6,8 value from the table. 6 from the numerator, 8 from the denominator. This is 3.581, or you can write as a 2 decimal places. Okay, or you can write as a 3 decimal places. There is no problem about that. So it means it is lies here, so we may accept it. It means this is accepted. It means this is my rejected. Hence the variance of 9.6 is cannot be regarded as greater than of the variance of second. Now look at the second type of this. Again your target is to estimate the variances. How you can take the variance? Again we will apply the F test. Now how you can do that? We can start with this. Vary differ significantly. How much differ? It is not given, so we can write here. Now in order to compute the value of the S1 and S2, we need this one. This is a sample 1 and this is a sample 2 given. Firstly, we need the value of x bar. What is the value of the x bar? That is sum divided by n. So for the first sample, I can take the sum of this. I can take the sum of this, and I can get as sum is 94 and this is 73. So therefore, sample mean and the sample mean of this is my here. Now after that, we need the value of the xi minus x bar square. So it is 11.75. If we subtract from here, this will be my 2.75 square. Similarly, from here we can get as a 0.75 square and so on. Similarly, for this we can compute yi minus y bar square. So after the calculation, you will get this number. I can substitute this value here. This is 33.5 and 1 minus 1. How many elements are there? This is 8. 8 minus 1, 7. And similarly from here, 23.7143. How many elements are there? 7. It's a 6 are there. Again, we can see S1 square is greater than of the S2 square. So therefore, F is my S1 upon S2, which comes to be here. Now, what is the degree of freedom of the S1? How many elements are there? These are my 8 elements. So the degree of freedom is my 7. In this case, there are the 7 elements. The degree of freedom is my 6. So we need the value at 7, 6. And it's come to be 4.20. Compare this value. This value lies here. So it means again it lies in the accepted region. So we accept H0, fail to here. So it means there is no significant difference between their samples variance. Look at the another one. Random sample of the 10 pigs which fed on the diet A, then increase in the weights is given to be here. While on the consist of the 12 pigs, they are increase in weights to be here. You have to estimate the population variance, whether they are significantly different or not. Again, we will start with the step number 1. Step number 2, again, we write all these values are here. We need the value of the x bar. We need the value of the y bar. So we can define the again as we did in the previous case, n1 and n2 are here. We can compute this value like of 12. It's my 2 square, it's a 4. It's a 6 square, 36. It's a 4 square, 16. It's a 5 square, 25, and so on. So we can compute like this. We can substitute this value in S1 and S2. Now in this case, you can see S2 square is greater than of the S1. So we can define the value of F here. What is the step number 3 is we need the degree of freedom. So in this case, firstly we have to write in the S2 degree of freedom. That is my N2. That is my 11. So this is case my 11 is my first degree of freedom, and the second is my S1, that is my 9. So in that case, we need the value as 11, 9 at the level of significance 0.05. 11, 9. So this value is come to be 3.112. Check whether this value lies. This value lies here. Again, we may accepted the H0. That is, there is no significant difference between their population variances. Okay, look at the one more example. Tests for the braking strengths were carried out on the 2 loads of the 7 and 9 are there. So N1 is my 7, N2 is my 9. The variances of the one load is my 230. So this is a variance of the one sample, that is a small s. What is the small s is? Sample variance. If it is given to you the unbiased estimate, unbiased variance, then it's a capital S1. This is my small s2 square. Is there any significant difference between the variability? What is the meaning of the variability? That is the variance. Now we again apply the F test. We have to check about these conditions. This is given to you. We have to apply the capital S1 square formula. This is the capital S1 square. We can compute this value from here. This is N1 S1 square, and here. Substitute all these values in this, you get this answer. Clearly says that S1 square is greater than of the S2 square. So we can take the F value as here. What is the step number 3 is degree of freedom. What is the degree of freedom of the S2 square is my greater than of the S2 square is greater than of the S1 square. So what is the degree of freedom of the S2? That is my 8, because 9 minus 1 is 8, and so second degree of freedom is my 7 minus 1, 6. So we need the value at 8 comma 6. So sorry, it's a 8 comma 6 are there. So because it's a S2, it's a 8 comma 6, whatever the value you can compute, check whether this value is 8 comma 6 is 4.15 or not. So I think this is a wrong value, so you can take from the table. Definitely it will be greater than of this. It lies 2.06 lies in the accepted region, so we can say we may accept it at 0, hence there is no significant difference between them. You have to check, carefully check, this number is 6.8, so you have to check this value from the table and check the you have to check whether this is accepted or not. Let me know the answer in the comment box. Look at the last example again. Say this is again the two samples are given to you. Variances you have to check that. So again, once you have there, you have to write the sample 1, that is a 2016 here. You have to compute the sample 2. You can easily compute these values from the table, and then you can write these values. Clearly says that S2 is greater than of the S1, so we can write here. What is the step 3? What is the degree of freedom is of the S2? S2 degree of freedom is my 11. Okay, how many elements are there? 12 minus 1 is 11, and this is my 10 minus 1 is 9. So we need the value at 11 comma 9. 11 comma 9 is given to be here. This value is 2 point again lies in this case, so we may accept it at 0. There is no significant difference between the population variances. So this is the way you can try to solve all these F distribution questions in a very simple with the help of 3-step rule. I hope you can like, share and comment this video with your friends. You can share this video with your friends and others. Best of luck students. Happy learning.